All right. Well, we're going to do lesson 2-1 here with the derivative. So we're going to split this up into two parts. We're going to start here with a kickoff. So determine all asymptotes of the graph of this here. So remember, asymptotes, we're just looking at the bottom. So we're going to factor that out. So we're going to be x plus 2, x minus 2. Now, we still need to factor the top, which will go to x plus 4, x minus 2. Because for it to be a vertical asymptote, it won't cancel with anything on top. So here, though, we do have the same factor. So those would cancel out. So that's not that it's going to be nothing. It'll still be a hole there. So it'll be a removable discontinuity. But what's non-removable discontinuity is the x plus 2. And that's what's going to be our asymptote. So if we go x plus 2 equals 0, we'd subtract the 2 over. So x would equal negative 2 is our vertical asymptote on this one. Now, what we're getting into today is derivatives. And to do that, we're going to use the difference quotient. Now, it's going to be a little different than what we did in the past. Here, we're going to use c plus change of x minus f of c all over change of x. C is going to be the x point that we're approaching, but we'll put c's in for now and we'll insert the numbers a little bit later. But we're really just finding that change in y over the change of x. And what we're going to try to do with this is define that slope, that second line. We want it to be as close, that second point I should say, as close to that initial point so we have no gap as possible. So we're going to use the limit as the change of x goes to 0. So as there's no gap in our x's, we're going to have an equation that'll give us our slope that we can put that x in, our c into it. So slope of the graph of f is going to be at x equals c. So whatever that x of our point is, which like for example here is 2, 1, so our x would be 2, that's the c. So at 2 is where we're going to try to find the slope of this. So we're going to use this equation and we're going to find the slope at that point. Now, this first one here, we could do this. Let me slide this over. We could do this one here already because it is linear, so we could look and see this slope. However, we're starting with an easier one so you can kind of see how this is all going to flow. So we would start off with the limit as change of x goes to 0 of our function where we're going to replace c plus change of x. So our function is 2x, so that x is going to become c plus change of x. Minus, well, we need our whole function, sorry, so minus 3. And then we're going to minus the original, so minus 2, but instead of x, we're going to make that a c. And then minus in negative 3 would be a plus 3 here. And we're all going to be over the change of x. So first thing I'm going to do is I'm going to distribute this 2 in. So the limit as change of x approaches 0 of 2c plus 2 change of x minus 3 minus 2c plus 3 all over change of x. So from here we can reduce. Now the 2c's are going to cancel, the minus 3's and the plus 3 are going to cancel. So all we're left with is the limit as change of x goes to 0 of 2 change of x over change of x. And it's off the screen. Sorry about that. So from here, we're going to reduce if we can. So change of x are going to be gone. So we're now the limit as the change of x goes to 0 of 2. Well, limit of any constant is just a constant. So our slope is going to be 2 at that point. Now, it's going to be 2 at any point because, again, we're linear there. But that's kind of how this is going to flow. So, going to get a little more complicated here. Find the slope of the graph at f of x equals x squared plus 1 at the point negative 1, 2. So again, this negative 1 is going to be our c. That's where we're going to approach. But we're going to find our difference quotient here first. So, limit as change of x goes to 0 of our function x squared. So, this is going to go c plus change of x squared plus 1. Minus the original, so c squared minus 1 all over a change of x. So this here, don't just distribute the square in. We have to FOIL this. And if we FOIL it, the limit as change of x goes to 0 would go to c squared plus 2c change of x plus change of x squared. So we have our plus 1 minus c squared minus 1, again all over change of x. So from here, we can cancel the 1's, cancel the c squared. So we're down to now the limit as the change of x goes to 0 of so we have 2c change of x left plus change of x all over change of x. Oh, this is change of x squared, sorry. So we can reduce now. So this change of x and change of x will be gone, and one of those will be gone. So now we're down to the limit as the change of x goes to 0 of 2c plus change of x, and there's nothing on the bottom. So as change of x goes to 0, that means this is going to go to 0. So 2c plus 0 is nothing. So we're going to end up with 2c. Now, c is going to be our x here, so we can put a negative 1 in. And so our slope at that point is going to be a negative 2. That's how this is all going to work. So, let me get this brought up again. My other computer shut off. Sorry. So that's where we're sitting right now. Now, if you get a slope of 0, it's automatically going to be a horizontal line. If it equals infinity or negative infinity, that's where we'll have a big over small type situation. 0 could be the other way where it's small over big. But then it's going to be a vertical line if it's infinity or negative infinity. So what we're really doing there is one of the two fundamental operations of calculus, which is differentiation. Remember we had those two problems from an earlier chapter that we said the two main problems in calculus are the slope problem and the area under a curve problem. So doing the differentiation is going to allow us to work on that slope problem. Now, really what the derivative is going to be, now here's going to be the official definition of derivative, but it's really what it's doing. It's like a reduction almost in our equation that's going to give us another equation that we could put any x in and we can find that slope. So we're going to be doing the limit as change of x goes to 0 of f of x plus change of x minus f of x over change of x. So differentiation is going to be that process of finding the derivative. And a function is said to be differentiable at x if the derivative exists at x and is differentiable on an open interval a to b if it's differentiable at every point in that interval. So as long as we can do the derivative anywhere on our graph, and we'll get into a little later of where it doesn't work, we'll be able to find the derivative of our equation and be able to find that slope then, that instant slope. So let's do another one here. Before we do that though, we have our different notation for derivatives, so how we write derivatives. More times than not, you're going to see it like this. And this is f prime of x. This apostrophe means prime. So that means this is the first derivative. You might also see it as dy over dx, which we'll get into more in another chapter. If we're dealing with y's, you may see y prime. You may also see d over dx or dx dy. We really don't do those. It should be one of these first three, more so f prime of x sort of a thing. But if we do this one here, and this will be the end of the first part, and then we'll stop the video and take a second part here. But we're still setting it up using that difference quotient. So the limit as change of x goes to 0 of x plus change of x cubed plus 2x plus change of x. So both of our terms have an x in it, so we have to sub in x plus change of x for that x. From there, we would subtract our original, so minus x to the third, minus your 2x. And it's all over a change of x. So again, we're not just going to distribute this cube into both. We have to cube that out, which it's going to go to this. So the limit as the change of x goes to 0 of x cubed plus 3x squared change of x plus I lost it. 3x change of x squared plus change of x cubed. So from there we continue on over minus x cubed minus 2x all over change of x. So limit as change of x goes to 0. We can start canceling. We can cancel x to the third, plus 3. No, not that one. Sorry, not that one. But I did not distribute that part in. So we also distribute the 2x. So I'm just going to put it on the end here. So plus 2x plus 2 change of x. So the 2x's will cancel. Sorry about that. So what's left is 3x squared change of x plus 3x change of x squared plus change of x cubed plus a 2 change of x over change of x. So we can reduce now. That one would be gone. One of these would be gone. This would go to a 2, and this one here would be gone. So we're left with the limit as change of x goes to 0 of 3x squared plus 3x change of x plus a change of x squared plus 2. So remember, all of our change of x are going to go to 0. So this has a change of x in it, so that's going to be gone. This has a change of x in it, that's going to be gone. So what we're left with is 3x squared plus 2. Now, that will be our equation we would use. We could pick any x, put it in for x, and that would give us our slope back out. And that would be our equation. So, I'm going to stop this half here, and then we'll start part 2 here in shortly here.